If you just want the quick explanation and you already know a bunch of stuff, basically what you have to do is you run through the color calibration and then you enable color management for all the color sensitive applications that you need to use, but disable it for the applications where you're going to be taking screenshots and screen capture, like screen video. Because if you don't, those colors will be ruined and there's no way to get them back. If nothing I've just said makes sense, just keep watching the video. I've done the color correction on this video for the screens, not for the room. So the room's gonna look pretty funky. Also, there will be timestamps and navigation in the description below and a link to a Reddit thread where you guys can discuss this and answer all of the questions that I'm going to have. This is Uncalibrated Terran, and here's Calibrated Terran. Wow, looks much better, I think. It's not enough just to get one of these color calibrator things, run through the software, and then you're good. You're not good. In fact, you're probably worse off than when you started because you don't know how it works. It's very important to know exactly what this does. I'm Terran Van Hemert, your reluctant host, and we're gonna go down the deep, dark rabbit hole that is color profiles and screen calibration specifically. Da-da-da-da-da, some kind of Terran intro here, yeah. Listen, I scripted this out. If you're confused about any of the vocabulary I'm going to be using, I made a super long document with you guys' help. Thank you very much. Read through the vocabulary section. So first, a question. How large is this Mario sprite? Is it 16 pixels across by 16 pixels high? No, it's not, because I zoomed in on it, right?
He is, in fact, 1024 physical pixels across by 1024 physical pixels high.
Right, and I can draw on him and you can see, yeah, there's only 256 logical pixels. A logical pixel is what makes up the image itself. A physical pixel is what makes up the screen. So that's really important for scaling and also for color, as I'm about to show you. Basically, you have 3 channels, red, green, blue, and they each can be anywhere from 0 to 255, for a total of 256 possible values, because 0 is a value, because computers start counting from 0. So you can see that I've got, you know, these little swatches here, and then I've got some samples from the image. That is my treehouse that I built. It's very cool. I'm really proud of it. So I have this loaded into Paint over here, and I have it loaded into Photoshop. And this will be very important later. Now, if I take a screenshot of the entire screen, and then I open that screenshot in Photoshop, all of the colors should be exactly the same as what we just saw. But let's check. Shot 1. Okay, take a look here. This is 101, 118, 117, 163. These colors are all the same. Oh, actually, I also need to check the Paint one to make sure those are the same. 97, 119, 49, 101, 118, 117. You can see it down here. Okay, these colors are all the same so far. What if I take a light? Have I locked off the ISO on this camera? Yes, I have. Good. And I shine it directly at the screen. There's a lot of screen glare right now, right? If I take a screenshot, will the screenshot have glare on it? If you answered, no, of course it won't, let me just stop you right there. In the context of a learning environment, never tell someone that something is obvious. Never respond with that. Never say, you should have known that, or of course it's that way. I have a whole video that I'm going to make about this because it is really important. But for the time being, just remove the word obvious from your brain. And we're going to check that screenshot. 101, 118, 117, 163, 96, 82. Okay, these look good. Oh, actually, I need to check Paint as well. I'm not even joking. 101, 118, 117, 39. Yeah, these all look good. So instead of saying that it obviously would have been exactly the same, an appropriate question to ask would be, why do you think that screenshot might have looked different? And the answer is, because this laptop has a webcam, and the computer has a feature called adaptive brightness, where it will change the brightness of the screen to match the room. The brighter the room, the brighter the screen, right? So, does that change the logical pixel values or not? And the answer is no, as we just learned. But I also need to check changing the brightness directly. Brightness, change brightness level. Here we go. All right. Because I don't know, but I suspect what's going to happen. Now, as you can see, the screen is much darker. Take a screenshot. And I need to brighten that up again because I can't see anything. We're going to open up shot 3 and check the values again. 97, 119. Okay, and these ones, I actually have to check paint as well. Now, maybe you already knew that changing the brightness of a monitor will not change the logical pixel values on that monitor. But have you ever actually checked it? Because it's not impossible that it would change those values. You might be thinking, well, it just changes the backlight. But for a device that's all OLED as its screen, there is no backlight. So it does have to change the physical pixel values, but leave the logical pixel values alone. I actually have checked it on this phone, bright and dark, to make sure that the screenshots are actually the same, and they are. Now again, you might think that this is all obvious so far, but remember that we are learning and there is no such thing as obvious. It is very important to lay down a solid foundation of understanding, because even if you've been right your whole life about how this stuff works, but you never actually checked it, you have been right for the wrong reasons. And if you're right for the wrong reasons, it's not very likely that you're going to be right about stuff forever, which is exactly what happens to me with this whole, oh shit, my monitor's been wrong for 6 years thing. So let's continue down the rabbit hole. If I put this orange gel on top of the laptop and then I take a screenshot, will the screenshot be orange? Screenshot. And let's remove this because I can't tell. Zoom in on this, and we're gonna check 97, 119 fully saturated colors. That looks good there. I'm also gonna check it in paint, and you'll see why. Okay, good. I've confirmed it in several different ways. But now let's try something else. Go to night light. Enter. What do we have here? Turn on night light. And look, it's orange, and I can see on the monitor that is orange. I'm gonna make it as orange, oh my God, as orange as possible. Oh my gosh, even the cursor is orange on this one, and it wasn't on my desktop. I did not know that was gonna happen. It's probably gonna work the way that I expected, but I don't know. Right, so now that I've put nightlight on, if I take a screenshot, will it be orange? Shot 5, oof, turn that off. It doesn't look orange, but we're gonna check it. Let's check 255, 255, let's check the orange color, 204, 107, 54, and back in Photoshop, 204, 107, 54. So, this screenshot was not super duper orange, but you saw how orange that screen was, and it wasn't a gel, like that was real. So what's going on here? What you just saw was an example of the logical pixels, the image on screen, remaining exactly the same even though the physical pixels are doing something completely different. There's some kind of software layer between the logical pixels and the physical pixels, which is effectively the same thing as holding an orange gel up against the screen, but it's done in software. And I proved it by taking a macro lens and pointing it at a screen to determine that, yes, those blue subpixels are completely off. I have also confirmed, can you see that? Changing the settings of your monitor does not change the logical pixel values. It merely changes the physical pixel values. Again, this is kind of that software layer between the logical and the physical. Hi, future Terran here. Past Terran forgot a couple of things, so I'm going to go through them with you because they're super important and it ties the whole thing together. Also, I just tried to record this and the recording on the screen failed, and I'm doing it a second time now. I really need a drink of water first. Holy crap. We don't need this. All right, listen. I can't show you the next thing in Photoshop because Photoshop does not have a feature called guide layers. And a guide layer is basically just a layer, like, you can add a layer like this, but it doesn't show up when you export. It's only visible in the interface. So I'll show you that in After Effects. So here we have the same image, and in fact, before I do anything, I do actually need to verify that the colors of this image are unchanged. 101, 118, 117, 204, 107, 54. Okay, that is unaltered, which is good. Now the next step, we're going to create a orange solid. And now because that's just way too orange, I'm going to put that to 50% opacity, and then I'm just going to use a multiply blend mode. And if you don't know how multiply works, don't worry about it. It's not important right now. This has been orangified. I'm not going to make the orange thing a guide layer yet. I am actually still going to check using print screen if this looks the way that I think it does. And let's see what the colors have become. 101, 102, 58, 204, 93, 27. As you can see, the red channel is actually unchanged, completely unchanged. Okay, and then how about these ones? Yes, the red channel is totally unchanged, but the other channels have been altered. So, back into After Effects. I'm going to right-click on this and say, where is it? Guide layer. Nothing has changed. The logical pixels are the same, and the physical pixels are the same. The only thing that has changed is that now, when I render this, it will not use the orange. That's it. And I actually should have done the experiment of like having this layer off and then rendering it and verifying that the colors are in fact the same. I should just do it. I should just do it. Save, render. And let's verify 244, 101, 118, 117. Good. Let's put the orange solid back. Again, remember, we need to make it into a guide layer. Here's an important thing, very important to know about. In After Effects, with a guide layer on, if I use the color picker right here, or, well, anywhere on the image, the colors I'm going to get are going to be way more orange. So the color picker is not ignoring the guide layer. Export, add to render queue, save. Now pay attention here. Notice how it's super orange right now, but as soon as I press render, oh, what's this? Oh, the orange goes away because it's rendering it without the guide layer, right? We have to check that now. We actually have to check 101, 118, 117, 204, 107, 54, and these ones are all where they should be. Excellent. Okay, everything is as it should be right now. All right, now this makes sense so far, right? There's just a layer on here. It doesn't have to be orange, it could be anything. And it's not rendered when you export to PNG. But it is rendered if we take a screenshot of it because that's what we're looking at. That's how monitor color profiles work. With the one exception that I know of, that the color picker would actually give you the correct color, the color that is underneath the guide layer. Just think of a monitor color profile as a type of guide layer, and you'll be good. And now we're going to do the final step, the thing that ties this all together, and the thing that ramps up the difficulty way more here. Turn that back to normal. And now I'm going to go to my desktop, and here's a little file here that's really going to throw a big wrench into the works. I'm going to make this file available on my GitHub. You can download it, you can play with it, just to see exactly how color profiles will work on your machine. But I received this file somehow when I plugged in a Dell monitor that I bought from Linus Media Group. This is a .icm file, and that is the type of file that you will receive when you do color calibration, right? So this particular one is more orange than it should be. It's like way more orange. It never worked very well. I don't know why they would ship that with the monitor. It's just terrible. But it works really well for a demonstration because it's obviously wrong. Copy, and we're going to paste it in C drive. Windows, System 32, Spool, Drivers, Color. That's where all of your monitor color profiles live. And now nothing's changed because we still have to apply it somewhere else. So Windows key, color management, enter. Okay, you're gonna get here. So we have two profiles available for this monitor here. There's also a second monitor right down here. I don't know if you can see it. This laptop has two monitors. It's kind of cool. So right now, I have, by default, no calibration on this computer. And you should check your own color management to make sure that you are also unprofiled, or uncalibrated, I should say. I think calibration and profiling are actually two different things. I have no idea. If you have some weird color profile on, and you didn't put it there, and you don't know anything about it, you are much better taking it off. Anyway, what we're going to do now is we still have to go here. We add, and we find, there it is, Dell 3008 WFP. Say OK. And now we set his default profile. Good. Now, click on the desktop. Nothing has changed. But if we click on Photoshop, ooh, did you see that? Did you see that color shift?
It became more orange. So, if we take a screenshot right now, will the screenshot be orange? In all the other tests, the answer was no. But this time, the answer is yes. But only under certain circumstances. Future Terran here. I'll just get straight to the point, shall I? Once again, I'm just going to apply the super orange color profile, set as default, close this down, and I'm going to click on Photoshop. Ooh, it changes. As you can see, versus paint, the colors look quite different. In fact, if I take another paint window and I blomp it up on top of Photoshop, you can see just how different they look. So if we open up the color picker in Photoshop and we ask it, hey, what are these colors? It will tell us that this one, for example, is 204, 204, 204, and that this one is 101, 118, 117, this one is 204, 107, 54. But we can tell that these colors are much more orange than they should be. And if you click inside of Photoshop and you drag out, you can actually select colors from other windows. So I'm going to check these ones, and look, it says 204, 204, 204, 101, 118, 117, 204, 107, 54. You see, Photoshop was lying to you. These colors are clearly more orange than these colors, but it will tell you the same result. And that is because, like I said, it is telling you the color value that is underneath the guide layer that is your display color profile. Maybe Paint will actually tell us what the real values are on this image. Unfortunately, Paint's color picker does not work outside of itself. So what I have to do is what I've been doing, which is take a screenshot of the whole screen, and then I'll just import that into Paint. And hey, Paint, tell me, what color is this? That is 212, 207, 190. What about this color down here? Is 116, 124, 107. That orange color is now 203, 114,
52. How interesting. Minimize that. Now here's the thing. If we open that same screenshot in Photoshop, it will tell us the truth this time about what those colors were. And immediately you can see that the Photoshop interface is more orange looking now. So if we ask Photoshop, hey, what are these colors? It will tell us the same thing that Paint just told us. 116, 124, 107. And this guy is 203, 114, 52. Instead of 204, this is 212, 207, 190. So it is now telling us the truth about what those colors were when I took the screenshot, but now because it's gone back into Photoshop again, actually the real colors that are on screen right now are even more orangified. So in fact, if I take a screenshot of this interface, open that up in Photoshop, and now it is double orangified. We could just keep doing this forever. Always asking it, hey, what were those colors? And it's always going to tell us the value of the colors before the display color profile has been applied to the colors, which makes them, in this case, more orange. So this is the main lesson of the day. Do not take screenshots of a color managed application because you get incorrect colors. They are just straight up wrong because they are only correct for your screen when it goes through one time.
However, when you export from or save as from Photoshop, the resulting colors are the ones that are underneath the display color profile. Those are what I call the true colors, the ones that the color picker is picking up. And that's what you want. Also, when you're saving an image, I always just use sRGB. I don't know about any of this other color profile crap that has to do with the image itself.
Now, despite this weirdness, display color profiles are a good thing to have, and you should have them if you're doing color sensitive work. You just need to know how they work. It is important to note that a change to the logical pixel values, the colors, will always change the physical pixel values or colors, or it's all done with voltages, it depends on the screen, but a change to the physical pixel values does not require a change to the logical pixel values. I hope this makes sense. Logical. Hi.
What's this video about?
It's about display color management.
Oh yeah?
It's horrible.
On this laptop or just
On everything.
Huh.
Yes.
So at this point, we are still using the horrible orange display color profile. Using it, I'm going to show you how to enable color management in various applications, starting with After Effects. And then later, I will run the color calibration software and create a proper display color profile.
So now, apparently what you do is you go to File, Project Settings, Color, and Working Space. It's going to be in here. But I don't see a 3008 anywhere in here. Like I've got this document open that says that it does look for it right here. It also said that it looks for it right here. Profiles folder, and then I'm going to paste it in there. Yes, administrators, blah, blah, blah. No, I do not see it. But let's just try sRGB, say OK, and ooh, what's going on here? It turned all orange. I don't know why selecting sRGB uses the orange profile that I installed. Anybody who's familiar with After Effects, let me know. And this is 203, 114, 52. But on this one, we have 203, 113, 51. For some reason, the way that the orange display color profile has been applied is slightly different in Photoshop and in After Effects. Like it's off by like one value for some of them. I don't know why. And now let's get to the final one, which is Premiere. You need to go to Edit, Preferences, General, and then look at this. This little checkbox right here, is this checked for you? Because if it's not, you've also been doing it wrong for forever. You have to have that checked or it won't use the color profile. So do that, say OK, and then this is going to change as soon as we say OK, so watch it carefully. Aha! They both got a little bit more orange, but only a little bit more orange. So let's check that with taking a screenshot. It's my only defense against the machines. Open that in Photoshop and check the color values. We've got 107, 123, 122, as opposed to 116, 124, 107. The values that I'm getting are totally different in Premiere versus both Photoshop and After Effects, which agree with each other mostly, but then Premiere is like some totally different thing, and I don't know why. I have no idea. So I actually have not done this, but I need to do this test on my main monitor, because like that's a problem if they don't agree.
Okay, long story short, my main monitor has the same problem. Here's the original photo. Here it is in Photoshop. Here it is in After Effects. And here it is in Premiere. Ooh. Premiere is a lot darker than it should be, and I have no idea why it's so different. If you have any idea, please let me know.
All right, now here's the thing. When you calibrate your monitor using one of these doohickeys or whatever, you will not get a profile that is as terrible as that super orange one. You'll get something that is probably just a less saturated version of what you have right now. Because in my experience, most monitors these days are oversaturated, right? Like especially TVs, they just look good. If, you know, in the store when there's like, oh, these bright saturated colors, but those colors are actually more saturated than they are supposed to be. The standard that we are all using supposedly is sRGB, which was implemented in 1996. And we're still using it. And Rec 709, BT 709, sRGB, they all have the same chromaticities, it's a vocabulary word for you, as one another. So everything that I'm doing here and that I'm showing you all just has to do with trying to get sRGB working properly. I have no idea how to get Adobe RGB working, or Rec 2020, or Wide Gamut. I have no idea. But you gotta start somewhere. So when I calibrated this monitor here, and I did it properly for once, it showed me this very interesting graphic which showed me how the reddest red and the greenest green that I had were really far away from where sRGB is supposed to be. So the effect then is that those colors have to be diminished, they have to be desaturated in order to get back to where you are supposed to be with sRGB. And you just have to assume that your audience is using a platonic ideal of an sRGB monitor to watch your content, right? We can't calibrate for grandma's pink TV. We have to calibrate for the perfect ideal and just hope that people's monitors are somewhere around there. Now, I had assumed that when you calibrate your monitor with one of these doohickeys, that it is effectively the same thing as going into your monitor menu and changing around these settings. See that? Red, green, blue. I've got color temperature over there. I've got gamma and all that other stuff. It's not the same thing.
In fact, changing those settings directly on your monitor is part of a proper monitor calibration procedure. That's the first thing that it should have you do, and it'll give you feedback because you have the little doohickey hanging on the monitor. Here are some pictures of that from my phone when I was doing it. Also, there are some monitors which can do that for you. I believe that this is called automatic display control, which is a very, very important point that most sources I have looked at just gloss right over.
Now this is DisplayCal, which is an open source software, which I tried, which I heard a lot of great things about, and which gave me a profile that was just no good. When I used the actual SpectraCal software from Portrait, everything worked out great, although that software is even more of a pain in the ass than DisplayCal. But you only need one copy of Calman Business, which it's on this computer right here, and you only need to install the client on each individual machine around the office, I guess, that you want to calibrate. Okay, we're going to install this and launch. First, what we have to do is, and they don't tell you this, and it's not anywhere that I've seen, but I figured it out. You have to hit your Windows key and you go to Display, and then you go Advanced Display Settings, go to Display Adapter Properties for Display 1, go to Color Management, then click Color Management again, choose the monitor, and then it looks like we've got two options here. We have Generic and we have Uncalibrated as a bypass. I was going to tell you that the correct thing to do is to go to Add and then choose sRGB IEC 61966-2.1. Say OK, and then set that as your default profile. However, all of these seem to be the same. I believe that if you choose sRGB IEC blah 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 blah, that it has the exact same effect as just doing uncalibrated. The point is that you have to make sure that your color profiles are not on before you start calibrating, okay? And I think this is the way to turn them off. I don't know for certain, but you'd think that that would happen automatically, and it doesn't. SpectraCal, guys, I'm looking at you.
Actually, as I later found out, it's probably best to turn off those color profiles through whatever software you had used to create them. The reason being, you have to also disable the one-dimensional LUT, which I'll get to later. This is screen capture from the second time I calibrated my main display, and I had an old calibration still on the machine, and as a result, all the colors were already desaturated, and calibrating it again caused them to be double desaturated. So again, turn off any calibration you have before you calibrate.
Are you serious? Why is this taking so long? What do you mean connecting to pattern source? Find meter. Oh God, what is this? Do I need to do this? Is that what? Test mode. And now we're waiting for Windows updates. Oh, why are you so frustrating? Oh, what is all this? You know what? I'm gonna restart this. Another update. Did that work? Searching for meters, nothing. Yeah, sure, go with these. So are you gonna work? No, this is, what the? That's not the monitor I'm using. Guys, I don't know what's wrong. So I'm just gonna show you how this works using a monitor that I was able to calibrate, which is this one, because this one has Calman for Business. So when you go through all of this and you got the little thingy against the screen, you get to the end and what the f?
Sorry, I couldn't figure out how to use the calibration software. You're on your own. Good luck.
Look, ignore all this bullshit going on over here and just listen. I have some screen recording from the first time that I did this, and I'm just gonna show you that, okay? But basically, when you first get to this screen here, there's a subtle but extraordinarily important thing that happens. There is a subtle color shift on the entire monitor, okay?
That is the application of a one-dimensional lookup table. I'm gonna restart the computer because that's when you'll see it. And I always thought that that was the color calibration. And it's not. That's only half the color calibration. And that color shift, by the way, that is changing the physical pixels without changing the logical pixels. So that 1D LUT is applied to the graphics card directly. And it turns on, I think, as soon as you turn your computer on. And it affects everything on your screen. So let me let you see it. Come on. There it was. That was the moment, that subtle shift. Color management. We're going to go to color management now. You are going to see that I have these three different ICC profiles. Right now, this guy right here is set as default. This is the one that I created using the Kalman client, Kalman for Business. And this is the best one. This has really fixed up my colors really nicely. It's good. This one here was created using that open source software, and it totally sucks, and I hate it. And this one here is, I think, effectively uncalibrated monitor. If you say set as default profile, holy shit, the colors did shift. What the heck? That wasn't supposed to happen. Oh, in the middle of trying to explain to you that changing these shouldn't change any colors on the screen, they all changed. If I actually go here, standard, bypass, standard. Whoa, okay. So, okay, I'm gonna have to check the screen recording to see what that was. You know what, I'm just gonna check it right now. Okay, thank God. My understanding is still correct. I believe what was happening there was that the 1D LUT was being applied and then removed, which is interesting. I thought that was a more permanent thing, but whatever. Boy, this is gonna be real hell to edit this video.
So, now we have a proper monitor color profile, which you should get working in all your applications the same way that I showed you for the super orange one. This is screen cap of me applying that proper color profile. And now, let's talk about the screen recording paradox.
Here's calibrated Terran, and here's uncalibrated Terran. Wow, he's ugly. Way oversaturated. This is uncalibrated Terran, and here's calibrated Terran. Wow, looks much better, I think. Now the thing is, if you're looking at the screen recording, it's gonna be the other way around. The good-looking one is gonna be the uncalibrated one. Paradoxically, if you have a color-calibrated monitor, or a color calibration, I should say, for a monitor, you can't do Photoshop and Premiere and After Effects tutorials and have the colors in those tutorials be accurate. Color calibration affects the logical pixel values. They've been altered and you can't undo that. So before you do a tutorial in Premiere or whatever, you have to go into the settings and turn off calibration. You just do.
But if you super duper need for your colors to be accurate and for the audience's colors to be accurate, here's the only thing I can think of.
You have to like split the HDMI signal or something and send one signal to a calibrated monitor and another signal to an uncalibrated monitor and record the uncalibrated stream, because that's the one with the correct colors. And before you take a screenshot of, of Chrome or Firefox, you have to turn off color management in Chrome or Firefox. And me, I just have them off all the time. So let's figure this out right now. Let's just do it.
Okay, so this is my good color profile that's loaded already.
As you can see here in Firefox versus Chrome, Chrome is much more desaturated. Let's check out Shutterstock's website. Look at the difference. Firefox, Chrome, Firefox, Chrome, Firefox, Chrome, Firefox, Chrome. Chrome is color managed by default. Firefox, Chrome. In Chrome, what you do is you go here. Chrome, flags, hashtag, force color profile. You'll just get to here. Instead of default, I'm just going to choose sRGB. Default is using your color profile. Relaunch. Let's take a look. Firefox, Chrome, Firefox, Chrome. Ta-da! They agree. Right now in Firefox, you go to About, Config, and type in color_management or something. Yeah, there we go. Now I've already set it to 0. I think 2 is the default, yes. And that's probably where I should leave it. Here's the documentation on this. Color management applied only to tagged images. I don't know. It's either going to be you're going to want 2 or 0. I can't tell you which one. I have no idea. Let me know if you know. Now that I've changed it, let's see if any of these change. Refresh. Those are the same. Okay. Now your screen recordings will look nice, even though your colors that you can see are oversaturated. There's such a thing as a reference monitor, which is so accurate that it's basically a scientific instrument. I don't know if there's like the buttons on the bottom, you just click them and then the pixels automatically change their physical values and everything just works. Like maybe that's what you would use for filming your tutorials of Photoshop or Premiere and having the colors be accurate for yourself and for the audience. I don't know. Somebody tell me how reference monitors work. I want a video of somebody using one. I want to see it happen. So we're gonna now move this. Look, this is a calibrated monitor, and Photoshop on this monitor knows what monitor it's on and it's calibrated for it. When I move this over, watch carefully. Watch it. Oh, what happened there? What was that? Oh my gosh, they became way more saturated because that is unprofiled. And it thinks, oh, I'm on this monitor over here. What color is this? Oh, it's 255. It's 255. I'm going to move this over, move it over. What color is this? 255. Same thing happens to this one. Yeah, see the change? It'll give you these values each time. You move it over, they all change, and it gives you the same values, right? So, Windows color management is really stupid. It should work per monitor all the time and only affect the physical pixels rather than being per application when it's just mostly on a monitor and changing the logical pixel values. It's total bull. And I think, from what I've heard, that Apple does a much better job of this. But you, poor suckers on a Windows machine, just have to know about this. Also, one more thing. Nightlight on this computer behaves a little differently. Check it out. Turn on now. Huh, look at that. The cursor is still white. See that? The cursor is still white. Do you understand the implications behind this? It is possible in software to show, to have a different effect to different parts of the same screen. The same screen. It is theoretically possible for me to move this over here, and this is in this monitor's correct color calibration, and this one is in this monitor's correct color calibration. It's theoretically possible that you would take a screenshot of this in Photoshop and it wouldn't be super desaturated. It would be only the physical values, the physical look of the pixels that have changed, without ruining the logical pixels. So, Windows, Microsoft, hey guys, what's the deal with this? Why does it suck so much?
Okay, so I have no idea if past Terran is correct. It might be the case that because of all the wider color spaces, Adobe RGB, Rec 2020, DCI-P3, and so on, that the only way to make this all work together is to change the logical pixel values. Also, it's possible the color management can't work the way that I want because you'd have to work very closely with GPU and monitor manufacturers, and those can't even agree on FreeSync versus G-Sync, neither of which should even exist in the first place, because why would you send only a quarter of a frame to the screen in the first place? You guys should have figured this out 20 years ago! There's a couple more things. There's more stuff. The color picker in Premiere for the titler, and also for making color mattes, gets the color that is above the color profile thing. You have to turn color management off, and then you can use the color picker, and then you can turn color management back on. This made me think, wait a minute, what about the color picker for Lumetri, which I use for auto white balance? Is that wrong as well? I checked it, and it is in fact not wrong. So, good on you, Adobe, for getting that correct. So I am concerned that because of the way that color profiles work, that it is changing around all the colors on here inside of 24-bit color space, right? 8 bits per channel. It gets super weird towards the blacks. It's skipping values. It's acting all funny. I can't show you this in a screen recording. I actually have to take a screenshot because partial versus full video, it's a thing. I wish it wasn't a thing. Whatever. So I'm going to take this and I will enhance it greatly for you, and you can take a look. Okay, so you can see this is dramatically exaggerated, but you can see how it is changing the colors. Like this is more red, this is more green, this is orange, this is blue. And then it kind of peters off and it becomes less ridiculous. You know what? I need to enhance that even further. Okay, so here's an extreme view of what it was doing to my colors. Yeah, I don't like the look of that. So like this should still be smooth. Like if I took, I guess, a 10 or a 12-bit screenshot of it, but it's not being stored in 12-bit per channel when it's on your screen. It's being stored in 8-bit per channel on your screen. It's being displayed that way. So I don't know. I don't know if this is what's supposed to happen. Let me know if you know anything. Oh, and there are several things that you can do to get your Photoshop colors working again, because there's a lot of situations where they kind of stop working. First thing, go to View and see if Proof Colors is checked or not. I don't know what proof colors I have. Okay, working CMYK. If I put that to Monitor RGB, oh, okay. This will actually toggle between calibrated and uncalibrated, I think. The other thing that could be screwing up your images is you go to Edit, no, you go to Image Mode, and you could be in grayscale, you could be in indexed color. I don't know how that works, but it really grabs hold of the image and doesn't let you do anything. It doesn't even let you add layers if you're in indexed color. Yeah, it's like you can only have these certain colors. I don't know, man. I don't mess with that. I find it really annoying. So just go to RGB color, in my opinion. And then 8 bits per channel, I mean, that's what I use, but I don't know what you do. I do video, so 8 bits per channel is fine. And then the other thing that could be screwing stuff up is color settings, and then there's assign profile, and then there's convert to profile. And I don't know the difference, but it's super important. Sometimes, some guys say that you should never convert. You should always, you should always convert. You should never assign. I have no idea. Here's the thing. Images themselves can have color profiles. Who knew? I didn't know that.
it's about 4 kilobytes worth of data, and most websites strip it away because it's too much. They can't handle another 4 kilobytes. So here is my understanding currently. All color spaces exist inside of CIE L star A star B star, also known as lab color space. And within lab color space, the borders of sRGB are well known. They've been defined since 1996. When you calibrate your monitor, you are letting your computer know exactly what's my own monitor's gamut. So therefore it can figure out where to put the sRGB gamuts inside of its own gamut, and it can also figure out the gamut of a photo inside of its own gamut. And I believe that what an image's color profile is doing is it's just giving a few bits of information. It's giving the red, green, and blue chromaticity coordinates. It is giving the illuminant, so I guess that could be coordinates as well. This is all in 3D space, by the way. But it's probably just D65 or one of the other ones that's like standard. Like you're not going to have the illuminant be red because it's based on the sun. The sun is not red. It's actually slightly green because it's a black body. Oh, these things get deep. It doesn't matter. And then it also probably has the gamma curve. And I don't know if there's any other bits of information that it requires.
So this visualization is just something that I created to try to understand this. And you can see that I put in exactly 256 little teeny tiny lines between each of those primaries and the illuminant. And I believe that this is how it works, where, for example, if you go from sRGB to Adobe RGB, the green just gets stretched out, and those little individual slashes, those individual points, get stretched out. So you don't have more bit depth to work with. You have the same amount. It's just stretched over a larger area, more into the greens and a bit cyan. So if you trust that your image is going to be displayed in a color-accurate monitor or setting or browser, you can actually use less than the full sRGB gamut and store your image that way. And then I believe that you'll have more steps in between each color. So you'll have like a greater color depth, I believe, for those colors that you are using. But I don't recommend you do this at all because the internet is the Wild West of color, and you're better off just sticking to sRGB all the time. Anyway, I found this guy Jeffrey's website. He talks about this stuff. I still don't understand a lot of it, but his funky RGB that he made, I believe, is just a color profile where red has been moved over to green, green has been moved to blue, blue has been moved to red, and then he kind of also changed the gamma curve, I believe. And this is how I visualize what the difference is. I might be wrong, but it's the best I got. Or maybe a color profile for an image is just a 3D LUT, and if it is, then it has the ability to change any color into any other color. But then we would still need lab coordinates. Maybe it's a hybrid of both? Somebody tell me how it works. Okay, hi. Listen, there's more stuff. NVIDIA control panel. Right-click on your desktop, go there. If you're using AMD, get wrecked. I don't know how to help you. Go to Video Color Settings. Advanced. Aha! By default, this is at limited, and I have put it to full. And this is, you can go watch a whole other video of mine about how to fix posterization in videos. And I talk about the agony that is full versus partial or limited video. And I actually don't know if putting this to full right here helps or not. But I have it set to full, and maybe you should as well. Somebody tell me. Bye. And thank you for any help that you can provide on all of these matters. I have a list of all the questions. Please comment in the Reddit if you're answering questions. It's just more efficient. The upvotes, downvotes, and discussion, it all gets saved in a way that YouTube comments just aren't very good for. And thank you for watching. I hope you learned something. Fun fact, this is the most miserable video I've ever made. And I hope that I don't have to dig any deeper than this, because it's an infinite black hole down there. That's all, folks.